with today we're talking about advanced factoring, like the hard stuff. We're going to start with easy stuff, but then move on to the hard stuff, which includes factoring by grouping. All right, this one, I'd like you to take a second and solve this one. I will pause. You should know how to do this one. It's one of those difference of squares. All right, you got 2x and 2x and a positive 12 and a negative 12. All right, how many had that one? Raise your hand if you did. Okay, you're all wrong. Did anybody do it better? Oh, okay. Mr. Seiler, what do you think? Okay. Oh, okay. So you're on the right track. How about if you just look at what I did so far? And actually, I'm okay. It's just I haven't finished. Hamish. 2 factors out of this one, x plus 6. And 2 factors out of that one, x minus 6. And then you put it all together. You can rearrange. The commutative property tells us we can rearrange things and they'll still be equal with multiplication. So 2 times 2 makes 4. And then I put x plus 6 first and then x minus 6 last. All right, that's the final answer. Now you could have also done that by noticing, excuse me, that there's a 4 that buried in both this one and this one, and you could have factored it out at the very beginning, the GCF. So by not looking for that, you broke one of the golden rules of always look to see if there's a GCF you can factor out first, because it'll make your life easier. All right, but it would have worked if you just noticed that, wait a minute, I can factor this farther, and I think I will. All right, now why are we doing this again? Because they start with a y equals, and I just kind of dropped my y, and those of you that did that on your test would lose a half a point. And your y equals can be set to 0. Why would I set the y equal to 0? Because that gives me the x, what? Intercept. And if I set that equal to 0, I can find my zeros. What's that 0? Negative 6. What's that 0? Positive 6. So it's got 2 roots. Does that match up with the degree 2? Yes, it does. So it all works out nicely. I want you to be able to pull it all together like that and say, well, I got 2 roots, and I should have 2 roots because that's what degree it is. Okay, moving on. This one is a lot like that last one. See if you can do this one smarter this time. Pausing while you finish. You have x to the 4th minus 4 left. That is correct. Does that look like a difference of squares? See. X squared. Then what? Plus 2 minus 2. Now, for extra bonus points, did anybody look to see if that could factor farther? That would have been smart to look. Now, it can't factor farther, but you should at least have looked because it's a difference of squares, potentially, because that's a perfect square. But that one isn't a perfect square, and therefore we can't factor it any farther. So it is factored all the way. But if I asked you for the roots, let's think about this. How many roots should there be? Just look back at the original problem. It should be 4. Because of this. Fundamental theorem of algebra says that if there's 4, at degree 4, then you must have 4 roots. Well, how am I going to get 4 roots? So I bet I have 2 roots in here, and I bet I have 2 roots in there. Who knows which ones are imaginary? The ones on the right or the ones on the left? The ones on the right. All right, here's how I can tell. I'm going to set this one equal to 0, because that's the point. I want this equal to 0, so the whole equation will crash. And then I want this side over here equal to 0. And then I just go the next little step, which is x squared equals negative 2, and x squared equals 2. You see how I solved that so far? Now, which of those looks like it's not going to work out so nice? The one on the left. The one on the left is the one that's going to have imaginary roots. So if I go square root on both sides, then I'll have absolute value of x. Remember that absolute value thingy. Your pre-calc teachers will beat you if you forget that it's an absolute value there. And then you have I root 2, And then to get the absolute value off of there, you just make it positive and negative I root 2. Over here, this is a lot easier because you just take square root and it doesn't have the I thing. And it's the absolute value of x equals square root of 2, and it's x equals plus or minus square root of 2. There's 2 answers. There's 2 answers. There's a total of 4 roots. All right. You get that? Did it follow through? Did it make sense? If I was going to graph this thing, would both ends go up or down? I know they go together because it's even, right? But they both go up or down? Up. All right. Next one. This is a plain old-fashioned factor it out, do the grunt work. Everybody try this one, please. I'll pause while you do it. So the first thing you should do is look for a GCF. Is there anything that's buried in all of these terms? Nope. And therefore, we move on to, it must be 2x and what? X. Then I ask myself, what could go here and here that would multiply and make negative 21? But it won't add and make negative 11. So how do I multiply and make 21? Well, there's 7 times 3, or there's 21 times 1. So it's got to be 7 times 3, probably. So if I'm going to go with 7 times 3, as I think this through, use logic with me. Wouldn't you agree this is a fairly large number? Therefore, if I'm going to put the 7 someplace, I better put it on the outside so that when I do the outside and the inside multiplication, that will end up being 14x. Gets me close to that 11. Okay? If I'd put it on the inside and I only put the 3 there, I'd only have 6. And that wouldn't be probably enough. So that's the way I'd probably think it through. It's not always going to work, but then I should think about my signs. One has to be negative, and I want this thing in the middle to be negative, so I should make my bigger number negative. That's another just general rule. It's not always going to work, but did that turn out to be right? Raise your hand if you had the same thing as I did. Okay, good. Then let's move on to this kind. This one's a lot like the one we just did. Doesn't have a leading coefficient, but it's got an x to the 4th in it. See if your brain is big enough to handle this one. X squared and x squared. You are so right. Okay. Now, do you think we can use that little rule where it multiplies to negative 6 and it adds to 5? Yeah, we can, because there's no number in front here. So, therefore, or there's a 1 in front, I guess you'd say. What multiplies 6 and adds to 5? But so does 3 times 2 actually adds up to 5. But what am I not really doing right? It should multiply to negative 6 and add to 5. So now I should use the 6 and 1 like you said. So I'm going to use 6 and 1, and which one should I make negative? The 1 or the 6? The 1, because I want the 6 to be positive because I want a fairly big middle term that's positive. Okay, so I need to leave that positive. All right, raise your hand if you had this answer. All right, you're all wrong again. Did anybody have something better than that? Hamish? Okay. All right, thanks for being honest that you didn't have it. Yes, this guy can break up into x plus 1 and x minus 1 because it's a difference of squares. People forget about 1 being a perfect square. So that now is the final right answer. Do you see what I'm saying? A lot of people would have lost a half, and it happens all the time. Every year, kids forget that they have this in their answer, that it's not factored all the way because it's a perfect square. This is a perfect square, and so is this. Get that? All right, so now let's do our root check. And I see this will be negative 1, this will be positive 1, and I'm supposed to have how many roots? 4. Is that enough roots? No, I got to have 2 more roots, so I got to have 2 more in here. And the roots on that one, well, please solve this one for me. X squared plus 6 equals 0. Solve it right now. Find your roots. Okay, so there's the work for making that into x equals plus or minus I root 6. Now, how many roots is that right there? That's 2, because it's a plus version and a minus version. So we got 1, 2, 3, 4 roots, just like we wanted.